Lightning. It's one of nature's most spectacular and potentially deadly displays. It is unpredictable, powerful, and strikes with unfathomable frequency.
There are between 6 and 8 million lightning strikes that occur worldwide every day.
What lightning really is in its most basic sense is it's a giant spark that's happening between two areas of charge in a thundercloud.
While natural disasters, such as earthquakes and cyclones, may claim more lives annually, the effects of lightning strikes can last a lifetime.
As electricity travels through the body, it can have significant impacts on the circulatory and nervous systems of the people that it comes in contact with.
There are after effects which can be definitive at the neurological level, with notable marrow damage and paraparesis, damage to both lower limbs, which makes it very difficult for people to walk again.
But how exactly is lightning created? And are there any positive benefits to this extraordinary phenomenon?
Paradoxically, while they are dangerous, they are a condition of life on the planet. If we had no more lightning, we would die.
Lightning is one of the most powerful phenomena on Earth. Each strike travels at a speed of about 128,000 kilometers per second. That's half the speed of light, and temperatures can reach almost 28,000 degrees Celsius. These dangerous bolts, only the width of a finger, are also one of nature's most recurrent spectacles.
Lightning strikes billions of times around the world every year, packing temperatures hotter than the surface of the sun and thousands of amps of current.
There are between 6 and 8 million lightning strikes that occur worldwide every day. That works out to an average of 100 lightning bolts that occur somewhere in the world per second.
Globally, lightning strikes cause over 4,000 fatalities a year, with more than a third of those incidents striking people who work outside, like farmers, or those who engage in outdoor recreation.
When there is a golf tournament, as soon as there is a lightning strike, the tournament stops. Because if the person points his club up to the sky, there is every chance that he will be struck by lightning.
At the PGA Tour's Western Open in 1975, 5 professional golfers were struck by lightning. All of them survived, while in some cases the injuries were career-threatening. For others, the injuries were career-ending. Today, most golf courses are equipped with lightning detection or early warning technology that allows course officials to call off play if there is lightning activity in the area. However, those same systems aren't in place for all outdoor sports.
Major League Baseball does not have a lightning policy. NFL does, but Major League Baseball does not. That becomes a huge problem for me. I'm the forecaster for the Indians, and I'm trying to tell them, guys, we have a big thunderstorm coming, you gotta shut her down. We can't shut it down until the umpire says we can shut it down. So I just sit and cringe and pray that nothing happens.
Organized sports are of particular concern due to the large amounts of people gathered. It is very rare that lightning strikes affect just one person in a crowd. Ground currents account for approximately 50 to 55% of all lightning strike deaths and injuries, and can affect several people at once.
More people are struck or impacted by what is known as ground current, when lightning strikes nearby and the electricity travels through the ground and then comes in contact with the person.
On September 16, 2019, in Kingston, Jamaica, a secondary school football match is disrupted when a lightning bolt strikes nearby, sending multiple players and a referee to the ground.
You see people playing football, and suddenly you hear bang, and they're all stiff on the ground. So it didn't strike anyone, but the lightning hit the ground, and it's spreading through the ground.
When a bolt, which contains at least 20,000 amperes of current, strikes land, the electricity spreads through the wet soil, which acts as a highly charged conductor. Even though the voltage decreases with distance, it is still a potentially deadly current, capable of traveling several hundred meters from point of contact.
It occurred in a soccer match when lightning struck nearby and the electricity traveled through the moist ground and up through the legs of the soccer players and the referee. As electricity travels through the body, it can have significant impacts on the circulatory and nervous systems of the people that it comes in contact with.
As electricity enters the body, it short-circuits the electrical signals that keep the heart, lungs, and nervous systems running smoothly. That disruption can cause cardiac arrest, seizures, or a host of other potentially lifelong pathologies.
There is a noise that is made, thunder, and the noise can cause a ruptured eardrum and sometimes permanent deafness. There are after effects, which can be definitive at the neurological level, with notable marrow damage and paraparesis, damage to both lower limbs, which makes it very difficult for people to walk again.
2 of the players are admitted to hospital after complaints of chest pain and are released the next day. Several players and some spectators report eye pain. Another player, failing to respond to treatment on the field, is carried out on a stretcher. He survives, but is unable to speak or move his left side.
What is less resistant to electricity is the central nervous system, the central and peripheral nervous system. All it takes is a flash of lightning passing through a nerve, and the nerve is paralyzed.
Nerve damage can also be caused by a different type of strike called side flash. It is the second most common cause of casualties and injuries after ground current.
In some cases, you can be struck by what is known as a side flash, and that is when you're standing under an object or near an object that has been struck by lightning, and the electricity jumps from that object into you.
In Dalian, China, an anchor for Dalian Weather TV is covering a storm from the rooftop of a multi-story building when lightning filled the sky. Feeling a shock in his forearm, he drops his umbrella and reports numbness in one of his hands.
With the reporter in China, it's possible that lightning jumped from the fence that he was standing near and the electricity traveled through his body. Now, when that happens, you can get nerve damage because there's a lot of electricity flowing through your body at that time. The nerve damage could cause tingling or numbness in the hand.
Wet soil and metal are both powerful conductors of electricity, and so are live trees due to their sap and water content.
Seeking shelter under a tree during a thunderstorm can be especially dangerous.
You could be struck. If you are standing near a tree, the tree could get struck and you could get hit too. And I just think a lot of people ignore that risk because they haven't directly been impacted by it before. Unfortunately, specifically with lightning, when you are impacted, it's too late.
On March 12, 2021, 4 gardeners in Gurugram, India, are taking shelter under a tree during a rainstorm when they are indirectly struck and knocked unconscious.
Most people lean against a tree with their back against the tree. It provides a direct path from the tree into the person's chest, which can then interfere with the respiratory system and impact the heart.
The victims are immediately taken to hospital, where they are treated for burns.
That electricity passes through the body and causes burns. not necessarily due directly to the electricity, but because of the energy inside. It can melt objects that you may have on it. And when you receive a burn, you absolutely must empty your pockets. Because it can melt keys, for example, which are in the pockets, and burn your legs very, very intensely, like buttons, like anything that can... coins. Anything metallic can lead to burns.
The third most common type of lightning strikes are called upward leaders, also known as streamers.
Lightning occurs, there's a downward leader from the cloud, and it's looking for a place to strike. Upward streamers emanate away from objects on the ground and then come into contact with the downward leader, creating that full lightning stroke. An upward streamer contains electricity and can actually electrocute somebody that way.
While lightning can cause significant bodily injury, its emotional effects can't be underestimated.
Depressive syndrome and fatigue sometimes affects 50% of people without knowing why. But we go from a status of good health to a status of bad health. So we mourn, and mourning is difficult to do, whether you are young or old. You go from being sick or even disabled sometimes. So inevitably, there is a personal depressive feeling.
To ensure the best chance for safety, experts recommend implementing one very important rule.
When thunder roars, go indoors. And whether you're on the land or in the water, the safest place to be during a thunderstorm is actually not outside. So whether you're in the water or on the land, during a thunderstorm, you need to immediately seek a lightning-safe place. And a lightning-safe place is a fully enclosed metal vehicle, like a car, or a modern building that has electricity and plumbing running through the walls.
Normally, if you have a full building with plumbing and electricity, it's a pretty safe building because any charge from the lightning that enters that building will probably be carried through the electrical or plumbing lines into the ground and be dissipated. Inside of a regular hard-topped car is also relatively safe. And that's actually because the car itself acts as what's called a Faraday cage, which is a giant metal box, and so any currents that interacts with that will be carried around that exterior of that metal box or Faraday cage.
But in one area not prone to thunderstorms, the shock and awe of a lightning show is simply too irresistible to ignore. Thousands of people flock outside for a first-hand glimpse of a rare, electrifying spectacle, despite the warnings to stay inside. There is a saying that lightning never strikes the same place twice. But over Lake Maracaibo in Venezuela, massive thunderstorms create lightning at least 300 days out of the year. Strikes can occur as many as 1,000 times in 1 hour, earning it a special distinction as the most struck place on Earth. Why? The region contains all the necessary ingredients for the perfect thunderstorm.
You have to have this warm, moist air that can be lifted into the atmosphere with high amounts of instability. Instability is when the atmosphere cools faster than the air that's being lifted into the atmosphere. When you have warm, moist air and a lot of atmospheric instability, like occurs in the tropics, in South America, in Africa, and Southeast Asia, you can get these prolific lightning storms that produce thousands to millions of lightning events over the course of a year.
Lake Maracaibo's unique topography assists in the formation of these storms. The Caribbean Sea flows into the lake, providing an endless supply of warm water, while the tropical sun pulls additional moisture. At dusk, strong winds whip through the surrounding mountains, forcing warm air high into the troposphere. This forms huge cumulonimbus clouds.
Notre cumulonimbus,
Cumulonimbus is full of water droplets.
ces gouttelettes
At a certain altitude, those water droplets turn into ice. Due to gravitation, this ice will then tend to descend, and through friction will actually generate electricity.
générer en fait de l'électricité.
We have a separation of electric charges, of charged particles, which will in fact produce electricity within this cloud.
Au sein de ce nuage.
A positive charge builds at the top of the cloud, while a negative charge builds at the bottom. Electrical charges between these opposites eventually grow strong enough to overcome the air's resistance to electrical flow, and sparks begin to fly.
Les prémices
The first signs of lightning actually begin with intra-cloud activity,
c'est-à-dire typiquement des étincelles
sparks that will occur inside our cloud.
Et puis au bout d'un
And then, after a while, this intra-cloud activity will propagate towards the ground and thus reach the Earth.
la Terre.
The negative charge at the bottom of the thundercloud moves towards the ground, forming an invisible path called a step leader. The charge's path connects to positive charges surging up from the ground, completing an electrical circuit.
This is what we call lightning strike, or in more scientific terms, the return arc.
While most people are familiar with lightning that strikes the ground, it only accounts for a small portion of what storm clouds actually create.
Cloud-to-ground lightning makes up about 10 to 30% of most thunderstorms. The other 70 to 90% of lightning in a thunderstorm is actually known as in-cloud lightning, which occurs within the cloud itself, between multiple clouds, or from the cloud to the air.
Though Lake Maracaibo's lightning events are exceptional, nearby countries Brazil and Argentina hold lightning records of their own. October 31st, 2018. Over the night sky of Porto Alegre, Brazil, a single bolt of lightning slices through the atmosphere. It stretches from the country's southern tip more than 700 kilometers or 440 miles to the edge of Argentina. Normal lightning flashes typically measure only a few miles long.
The lightning that struck and traveled 440 miles was a primarily in-cloud lightning flash that occurred in a mesoscale convective system. A mesoscale convective system is a very large complex of thunderstorms that can extend for hundreds or thousands of miles.
The clouds in these giant systems have the potential to create vast amounts of electrical energy.
And because these occur in large complexes, there's a lot of electricity traveling through all of the clouds. And lightning wants to dissipate that charge and and get into a neutral state, and wants to have a cloud that has no charge. So when there's a lot of electrical charge, there's a lot of potential for the lightning to travel around through the clouds in what a lot of people think of as spider lightning. And that is the horizontal lightning that you see extending along the bottom of clouds, and it's trying to use up all of the electrical charge in these large clouds.
Another record-breaking strike takes place in central Argentina on March 4th, 2019. It lasts 16.73 seconds and is the longest-lasting lightning strike on record.
The lightning strike in Argentina was another very long-lasting in-cloud lightning flash. And it lasted over 15 seconds. Again, this was in a mesoscale convective system. A lot of these occur in South America and in the Great Plains of North America.
The Great Plains state of Oklahoma is, in fact, the previous record holder for the longest in-distance flash. It occurred in 2007 and was 321 kilometers long. The longest in-duration record is held by one bolt that flashed over Provence-Alpes-Côte d'Azur, France in 2012 for just under 8 seconds.
Si vous prenez une ligne entre
If you draw a line between Bordeaux and Strasbourg, well, the south of this line corresponds to the most struck by lightning.
particulier en été.
Lightning occurs most frequently in Italy and France, with France seeing thunderstorms 250 days out of the year.
Dans certaines zones,
In certain areas, such as the southeast of France, there are periods of so-called Mediterranean storms, the famous thunderstorms that we used to call Cévennes, and which, on the other hand, occur at the end of the summer, and typically in September.
en septembre,
A Cévennes episode consists of very violent and highly localized storms formed when warm and humid air from the Mediterranean heads north into France. When it hits the mountains of Cévennes, it meets the cold air at high altitude, resulting in thunderstorms. These storms typically happen in autumn and can last for several hours.
exemple ceux de Nîmes en septembre.
In Nîmes, in September 2002, a stationary thunderstorm produced lightning for more than 10 hours.
Pendant plus d'une dizaine d'heures, et les habitants de Nîmes
The inhabitants of Nîmes saw lightning non-stop.
sans s'arrêter.
The stationary storm in Nîmes, like the ones in South America, were also part of a mesoscale convection system. The storm resulted in catastrophic flash floods and at least one lightning fatality. At the other end of the spectrum, both the North and South poles are the least likely to see lightning. Thunderstorms need to follow the basic recipe of rapidly rising warm, moist air colliding with cool, dry air above. But at high latitudes, that hotter, moist air is far less common. Those ingredients are also less common off the west coast of the United States, particularly California.
California doesn't typically see a lot of lightning in a given year. The Pacific Ocean and its cool waters near the west coast of the United States help to impede the development of thunderstorms. So when lightning occurs in Southern California, the Bay Area, or other parts of California that aren't typically lightning prone, it gets a lot of attention.
In February and March of 2019, Southern California is battered by a string of thunderstorms. They are spawned from a weather event known as an atmospheric river, one of Earth's conveyor belts that moves heat and moisture from the equator towards the poles.
An atmospheric river is a high-altitude river of high moisture that came from the Pacific Ocean into the west coast of the United States. Associated with this river of moisture were strong winds in the upper levels of the atmosphere, helping to trigger a large number of showers and thunderstorms, producing a lot of rain over a 2-week period over Southern California. In addition to all of this rain came thunderstorms.
So in a thunderstorm, when you have all of this rising air, you have all kinds of stuff rubbing together, and that creates an electrical charge, and that electrical charge needs an outlet.
On March 5th, these powerful thunderstorms produce an unusual and enormous amount of lightning that is seen all the way from Los Angeles to Santa Barbara, a distance covering over 145 kilometers. 2,000 cloud flashes and 1,000 cloud-to-ground strikes are reported in just a matter of 2 hours.
Having a significant lightning event like this, where you had 2,000 lightning events that occurred in just a couple of hours, makes up a significant portion of the yearly lightning of Southern California in a very small period of time. This can have significant impacts on the region, including power outages, potentially injuring or killing people if they were to be struck by lightning, and even triggering wildfires.
This rare lightning show turns into an evening spectacle. Thousands of awe-struck residents flock outside to capture the event on their cell phones. The Weather Service issues warnings on social media for residents to head inside.
I think the big thing about thunder and lightning is, having an awareness about it. People get very cavalier attitudes when there's a thunderstorm around. A lot of people want to go out and look at the thunderstorm rather than take cover. And that's something that's pretty annoying as a meteorologist. I appreciate and I understand that power. And I want to tell people of that power, but they're fascinated by it. They want to go look at it.
Fortunately, no injuries or deaths are reported, but several areas suffer power outages. A few small wildfires are ignited, and shortly after a plane takes off, it's struck and is forced to land.
You don't want to fly an airplane into a thunderstorm. That's a bad idea to start with. But they're designed to be able to handle that if it does end up flying into an area where there could be lightning.
Aircraft are insulated from lightning. The electricity actually travels around the body of the aircraft. So for the most part, aircraft are safe from lightning when it occurs, and the electronics in the aircraft are not affected.
While thunderstorms always have lightning, lightning doesn't always need a thunderstorm. Perhaps there is no better example than the mesmerizing lightning show created by the tall volcanic eruption on January 12, 2020. June 4, 2020. Lightning strikes the 168-meter-tall Washington Monument in Washington, D.C., injuring 2 National Guardsmen.
We're part of a very large thunderstorm that actually injured some people as a result. We went back and looked at the data, and we found that the Washington Monument is struck between 1 and 5 times per year on average.
May 28, 2018. The Eiffel Tower, with a height of 324 meters, is struck by lightning as thunderstorms sweep across the country.
It is estimated there are between 5 and 6 lightning strikes on the Eiffel Tower each year.
The Empire State Building in New York City is struck about 25 times a year. How do these structures withstand such massive electrical charges? Is there any truth to the myth that lightning always strikes the tallest object?
Because of its prominence, its size, it will have a capacity for attraction. However, the day you have a lightning strike, which occurs a few hundred meters away, you can legitimately ask yourself why this lightning did not strike the Eiffel Tower, and that is a question of probability.
The higher that an object is in the sky, the closer it is to the source of electricity and the more prone they are to being struck. So tall objects like TV antennas, wind turbines, or large buildings can be struck more frequently than others. Just because there's a tall object doesn't mean that's going to be the lightning that's struck. The entire lightning event occurs at about 200,000 miles per hour, and it's jumping at about 50 meters per step in the lightning process. Whichever object gets struck released an upward streamer of electricity that was able to interact with the downward leader of the lightning before another upward streamer. So it doesn't always have to be the tallest object. It's the object that released the electricity that came into contact with the lightning first.
However, because tall structures and buildings are more prone to lightning strikes, they have been designed to withstand them.
But skyscrapers have been designed for a long time to be able to withstand lightning strikes because they're very tall objects. They attract lightning very well. Normally, if you look at the top of a skyscraper, you'll see a bunch of little rods sticking out as part of lightning rods and as for some charge dissipation. So what happens is it's an area to focus that current, and then it takes that current and then drives it around the building and to ground, so that if the building is struck, it's not a risk to anything inside the building.
The principle of a lightning conductor is to capture this electricity and then to conduct it along the ground to render its effect harmless, both for the installations and for people. In the case of the Eiffel Tower, imagine that this structure is completely metallic. In other words, when the lightning current propagates, it will actually follow the metal structure of the Eiffel Tower, and therefore, inside the Eiffel Tower, most people will be protected.
Though tall structures might be more susceptible to a lightning strike, the fact of the matter is, lightning can happen anywhere.
It is not possible to determine with certainty whether the lightning will strike on such and such street, for example, or rather on another street, or even worse, on such and such building, or that one, which makes it dangerous.
Lightning can even strike as far as 40 to 80 kilometers from the parent thunderstorm.
There are some instances when the anvil of a thunderstorm can be pushed very far downwind of the actual core of the thunderstorm, and you get lightning 25 to 50 miles away, but that is very rare.
These strikes are referred to as a bolt from the blue.
Occasionally, you get a lot of electricity near the top or the side of a thundercloud. As the electricity looks to discharge itself, sometimes it finds that discharge point miles away from the thunderstorm. That occurs as a bolt from the blue.
Typically, these bolts travel from 9 to 16 kilometers from the storm. They are also much stronger than a bolt coming down directly from a thunderstorm cloud.
And this is because you have larger distances between the source of electricity, the thunderstorm, and the discharge point. So you need to have a more powerful lightning stroke to bridge that distance and cause that lightning.
Even though bolts from the blue occur miles away from the thundercloud, they are still caused by a thunderstorm.
Every thunderstorm produces lightning because that is the very definition of a thunderstorm. That is to say, for the World Meteorological Organization, a thunderstorm is simply a phenomenon where at least one electric arc will occur.
However, lightning itself is not as dependent. It doesn't always need a thunderstorm to spark.
Aircraft can trigger their own lightning, and this occurs when a plane takes off and flies through a charged area of the atmosphere. It gets electric charge on the outer body of the aircraft. And as it continues to fly through regions with different amounts of electrical charge, it tries to dissipate that charge, and that can trigger its own lightning flash.
You can shuffle your feet on a carpet and zap somebody. That's static electricity, and that's kind of where things get going in the atmosphere, just on a vast scale.
Lightning can even happen in severe snowstorms. This phenomenon is known as thundersnow.
A lot of times this is actually triggered by tall TV towers or wind turbines because they're closer to the cloud base in the wintertime. And because there's an electric charge at the base of the cloud, and there's electric charge then near the top of these wind turbines or these TV towers, you can get a discharge which is known as thundersnow.
Perhaps the most well-known cases of lightning without a thunderstorm come from volcanoes.
Volcanic lightning is extremely exciting because it combines two of the greatest powers on the planet, volcanoes and lightning. Volcanic lightning is similar to, but different from meteorological lightning. In a volcanic eruption, you have an explosion of ash, magma, tephra, and sometimes even water in this volcanic eruption. And as all of those particles are colliding in the eruptive plume, you get static charges that then discharge as volcanic lightning.
Before January 12, 2020, Taal volcano in the Philippines was a large caldera filled by picturesque Taal Lake, whose 267 square kilometer surface plunged as deep as 172 meters. After 40 years of slumber, the volcano suddenly awakens. blasting through the lake and spouting ash into the stratosphere. Within this gigantic plume develops an amazing lightning show. The explosion causes billions of super-hot ejected particles to collide and then separate. In addition, the plume reaches so high into the freezing stratosphere that water ejected during the blast converts to ice crystals, turning the explosion into a dirty thunderstorm.
And this was a phreatomagmatic eruption. And what that means is that there was a lot of water in addition to the magma that was erupted, because a tall volcano is actually in the middle of a lake. As a result of the water, magma, and ash rising through the atmosphere, there was a very dramatic explosion of volcanic lightning.
Volcanic lightning is not uncommon, but the amount found in Taal's powerful eruption was out of the ordinary.
More than 30,000 lightning events were detected in the Taal eruption over the course of 15 hours.
Yet despite the incredible number of lightning flashes, the Taal volcano did not break the record.
In late December 2018, Anak Krakatau volcano in Indonesia erupted and produced the most volcanic lightning that we have seen on record. More than 300,000 lightning events were detected over the course of a week in that volcanic eruption.
It surely provides a jaw-dropping spectacle for us, but volcanic lightning is not only shock and awe, it's actually a useful tool for meteorologists.
Volcanic lightning is extremely interesting to study as a lightning scientist. It provides more information about what's actually occurring in the volcanic eruption, and it can help us to better understand meteorological lightning as well. Because we don't have to identify where lightning may potentially occur, because it's going to occur right there during that volcanic eruption, having the instrumentation around the volcanoes allows us to directly measure and study certain aspects of the lightning process, whether it's the pre-lightning electrification of the ash cloud or the exact trajectory that the lightning takes through the ash cloud.
In turn, those studies assist with public safety.
It's important to understand the exact process of how lightning develops and how lightning occurs so that we can use that to better understand when lightning will occur in meteorological instances, which will improve weather forecasts, improve lightning forecasts, and improve lightning safety.
Lightning can also occur within another type of natural disaster, the wildfire. In August of 2020, the state of California is besieged with wildfires. But these fires aren't just the result of lightning, they are also the cause. August 2020. The state of California is ablaze with wildfires. Over 4 million acres are charred, forcing mass evacuations. It is the largest wildfire season ever recorded in California's history. At the core of the crisis is dry lightning. It strikes 11,000 times over the course of 72 hours, and there simply isn't enough rain to put out the sparks.
Dry lightning occurs when a thunderstorm produces very little precipitation, but a lot of lightning. In these instances, they're particularly dangerous for wildfire applications because the precipitation that would normally help extinguish a fire is not there, and the lightning that would trigger the wildfire could trigger a fire that is not easily put out.
Dry brush and high winds not only fan the flames, they spur the fires to create their own weather. As a wildfire billows into the sky, a vigorous updraft lifts particles high into the atmosphere. These particles act as condensation nuclei, attracting water molecules to form a storm cloud called a pyrocumulonimbus cloud. These fire clouds produce their own dry lightning, the same phenomenon that triggers the fires in the first place. It becomes a vicious cycle, and it appears to be getting worse. 9 of the state's largest fires have occurred since the year 2000. This leads many to ask, is global warming to blame?
As temperature is one of the necessary ingredients for the formation of thunderstorms, it can be assumed that an increase in temperature will mechanically generate more thunderstorms.
If climate change causes surface temperatures to warm and not the rest of the atmosphere, you could have more instability in the atmosphere, which could produce more thunderstorms that could produce more lightning. However, if the entire atmosphere warms, instability in the atmosphere could actually be decreased, which would reduce the amount of lightning. So climate change and lightning will be a topic that needs to continue to be researched over a longer period of time as we have longer and longer records of global lightning data.
While reduced lightning seems like a good way to mitigate its destructive forces, life on Earth would be severely threatened. For one, lightning produces ozone, a vital gas in our atmosphere that helps shield the planet from harmful ultraviolet sunlight. Without any lightning at all, life would cease to exist.
Paradoxically, while they are dangerous, thunderstorms are a condition of life on the planet. They contribute to recharging the Earth's atmospheric field with electricity. We need electricity. If we didn't have thunderstorms, if we didn't have lightning, what happens is what is known as a leakage current, which actually tends to discharge the Earth of its electrical capacity.
Lightning helps transfer negative charges to the Earth, as the Earth releases a positive charge. Without this exchange, the electrical balance between Earth and the atmosphere would disappear in minutes.
According to some scientists, it would only take a half an hour to see us die if thunderstorms and lightning stopped on the planet.
Lightning is vital, and it demands to be respected, whether on land or over water. Lake Victoria is the largest lake in Africa and provides economic and food security for roughly 30 million people living near its shores. But the lake is also deadly.
One of the most dangerous areas on the planet is Lake Victoria. There are about 5,000 deaths every year on this lake. It's fishermen who continue their subsistence activity, and unfortunately, they are struck by lightning because it's one of the most struck areas on the planet. And when you're on a lake, well, there's no way out.
The conditions of the lake spawn cyclical lightning storms. As daytime breezes flow off its relatively cool surface toward the warm, humid land, the interaction of temperatures invariably forms thunderstorms over the water.
Being in the water during a thunderstorm is especially dangerous. Water can be a very good conductor of electricity, and if you're in a body of water, lightning striking that body of water could very easily transfer the electricity from the water to you.
Though any kind of lightning has the potential to be deadly, there is one type whose power goes unrivaled, the Superbolt.
Lightning that occurs over the ocean tends to be more powerful than lightning that occurs over the land. Some of these lightning strokes are tens to hundreds of times more powerful than the lightning that occurs over the land, and these are what have been colloquially named superbolts.
Superbolts release anywhere from 10 billion to 1 trillion watts of electrical power. That's enough to power an average home for an entire month. Why superbolts form over the ocean and why they are so strong is routinely debated. One likely theory points to salt. In water, salt splits into positive and negative ions that help conduct electricity. When lightning strikes, the more ions present, the more efficient the electrical charge. which is why salt water makes a better conductor for electricity than fresh water. That discharge causes a higher peak current and a brighter flash. Fortunately, superbolts make up less than 0.001% of all lightning strikes. Nevertheless, being caught at sea during a thunderstorm, superbolts or not, is less than ideal.
When lightning strikes a body of water, these impurities can actually help conduct the electricity for greater distances than if it were just to strike soil or another object on the land. If there are objects, people, fish, boats, or anything near that lightning when it strikes, that electricity can transfer from the lightning to the water and then to those objects that are near the lightning.
Most lightning strikes over water occur just off the coast versus over deep ocean areas. Because of this, moored boats are especially vulnerable, like this sailboat docked in South Boston Harbor. The current hits the mast and travels quickly through the boat, setting a portion of it on fire. No one is on board and no injuries are reported nearby, but its fuses are blown and the boat sustains significant electrical damage.
While boats cannot be totally protected from lightning, you can add lightning protection to boats that help to direct the electricity away from sensitive objects on the boats, like equipment room or the passengers on the boats.
Just like tall buildings and structures, boats can be equipped with lightning conductors. However, there are numerous places around the world where conductors aren't feasible, and thousands of lives are at stake. Florida, August 2020. Lightning strikes the Millennium Falcon ride at Disney World Resort. As a precaution, the park shuts down the ride.
Anytime you're dealing with large crowds of people outdoors and a thunderstorm comes in, that is a huge problem. You have huge, very tall, hundreds of feet tall metal roller coasters sticking up into the sky, and thousands of people, tens of thousands of people out and about at that park. Now you throw a thunderstorm coming that way. Now not only do you have to have time to shut down the rides, you have to be able to get people into some kind of a shelter. And when they may not necessarily have a frame of reference for where to go to find security, they're gonna just panic. And there have been cases where, you know, thunderstorm rolls in, people just stick it out. They'll just park themselves in a picnic shelter or something somewhere. That's not necessarily the safest place to be.
A big part of things we can do to improve our response to lightning is being able to better predict when and where there will be lightning so we can take the good precautionary measures. That knowledge is very important, an important direction that lightning research is going.
Hey baby, slow down, wait for me. Pretty rocky here, hey.
The study and tracking of lightning and thunderstorms are the means by which meteorologists help mitigate the dangers of this unpredictable, powerful phenomenon.
So there's three primary categories of instruments we can use to study lightning. So the ones that you would see maybe on a TV broadcast are going to be studying where there's a large amount of current being transferred in a thunderstorm. So you're measuring that point where it's striking ground. We can also use satellites. We have some brand new satellites that were launched a few years ago, which are studying where there's optical lights being emitted by the lightning in a thunderstorm. So we have that visual reference of what the lightning looks like at the top of the cloud. And then our third and final way are a lightning mapping array. And what that does is it measures the radio frequencies being emitted by lightning, and we can actually map out the channels that the lightning takes within a cloud so we know where the lightning starts and how far it travels and what height it's at.
French lightning detection company Meteorage also uses a radio frequency sensing network that constantly scans the electromagnetic field variations created by lightning.
One of the most interesting applications of these detection systems is to anticipate a real risk of a storm on a site in the next half hour, or even an hour. It is from this anticipation of the displacement of the storm that we warn an incalculable number of sites which need to be alerted to be able to set up measures for evacuating personnel, or even to protect certain processes sensitive to storms. When you work in the construction industry, when you work with the aviation sector, when you work with the electrical sector, these are entities, large entities, that have high expectations in terms of safety. And in fact, this obliges us to put in place enormous means to ensure their safety.
As soon as a radio frequency signature is detected by the sensors, lightning measurements and locations are transmitted to the company's central operations in a mere matter of seconds. Then warnings are immediately dispatched.
On a very busy day, it is not uncommon to send more than 30,000 messages. These calls can be voice calls, can be sent by SMS. And so, in this example, I myself received a text message indicating an alert, thunderstorm approaching, put in place your preventive measures. And so, presto.
These warning systems and tracking devices are helping scientists save lives. But they still aren't 100% foolproof. The best course of action still remains to be weather aware and to head indoors when thunder roars.